All right, for this one's a little bit more complicated because we have both constant velocity part and changing velocity part. So we want to make sure we draw it correctly. So we have an elevator. So let's say we have an elevator right here, traveling up at a constant speed from the ground to the 30th floor. So let's say that's what it is in 18 seconds. So it traveled 90 meters in 18 seconds. Okay. Then a bolt, so let's say there's a tiny little bolt right here, breaks off, and then the bolt comes down. All right. So before we get to the bolt, I want to get a couple things down. Is what's the speed of the elevator? So this one is a constant velocity one, so we're going to use this equation, d equals vct. So it's pretty straightforward. We know the displacement is positive 90. We know the time is 18 seconds. So we just solve for vc, which should be a positive number, and I believe it's 5, but let me just double check. 5. So velocity constant is 5 meters per second squared. Sorry, meters per second positive. Divided by 90 divided by seconds meters squared. All right, perfect. So we know that the velocity that it's moving constantly is 5 meters per second up. All right. It says, what's the velocity of the bolt when it's when it breaks off the elevator? And this is kind of what we have to know. So when it's here, the bolt right here is moving with the elevator. So if the elevator is moving 5, that means the bolt's moving 5. So when it breaks off, the bolt doesn't just drop down. It continues its upward motion first, and then it starts to fall back down. So what's the initial velocity? It was also positive 5 meters per second. Oop, let me do that better. So like I said, it was also positive 5 meters per second. Okay. Now we want to know the final velocity of when the bolt hits the ground. So let me just make sure. Okay. So let's set it up. So we know VI, VF, ATD. Let's figure out what we do know. We know VI is positive 5 meters per second. A is negative 9.8 meters per second squared. And what do we know? We know one more thing. It started from the ground floor. It traveled 90 meters, so the displacement was positive 90. Now here's the tricky part. It says, what's the final velocity when it hits the ground? So if this is 90, even though it's 90 up, it's going to travel 90 down. So make sure you get your right. I initially got it wrong. It should be not positive 90, but negative 90 because it's falling down. Okay, so now we have 1, 2, 3 of the variables. We want to find final velocity, so that in this case, this one. So we're going to use the equation without t, so that's vf squared equals vi squared plus 2ad. Plug in everything you know. 5 meters per second squared plus 2 times negative 9.8 meters per second squared times the displacement of negative 90 meters. Okay. That's 25 meters per second. Both of them are squared. This one I cannot do in my head. So 2 times 9.8 times 90 gives us 1764 meters squared over second squared. And the unit here is positive, so we're just going to leave it like that. You add these two together. They have the same unit, so you can. So you get velocity final squared equals 1789 meters squared over second squared. Take the square root of that. And I get 42.3. Plus or minus. Now you have to decide. Final velocity is going to be negative, so final velocity is negative 42.3 meters per second. Okay. How much time does it take? So you do the same thing, but this time you're going to solve for t. So that one, the easiest one, VF the one with T without VF would be this one. And in my previous problem, I said I hate doing this because you're going to have a polynomial. And if I plug it in, I'm going to get a polynomial. And I'm going to leave out the units just because it's going to get pretty nasty. Actually, I'll leave it in. VI was 5 meters per second. T plus 1/2 negative 9.8 meters per second squared times t squared. So, do we have to do this? The answer is no. We know final velocity. Let's take advantage of it. So the easiest equation for time is this one. So why not use it when you know it? So negative 42.3 equals positive 5. I left out the units there, but it's meters per second. Plus negative 9.8 meters per second squared t. So I'm going to take advantage. I'm going to move the 5 over, so you get negative 47.3 meters per second divided by that entity, negative 9.8 meters per second squared, equals t. So t is equal to 47.3 divided by 9.8. And I get 4.83. But we'll just round it off to 4.83 seconds. So much easier. So when that comes to the point where you could take advantage of already knowing the answer, please do. This will give you the same answer, but you have to do the quadratic formula, which is a pain, unless you have a already program in your calculator, which is totally fine. Now, if we know this one, when the bolt falls off, the elevator is still moving at constant speed. So it's still moving at 5 meters per second. So if that is true, then we could also do this one, VCT. Now we want to know D. It's still moving at 5 meters per second. The new time that we added was 4.8 seconds. So that would be so it traveled another 24 meters positive. All right. So this will move another 24. The bolt goes up, falls back down, and that's kind of our final picture. So just remember, when you're on something, so let's say you're in a car and you throw something out of the window, it seems like it goes straight backwards, but it actually goes forwards first and then gets shot backwards. It's a little bit more exaggerated because in a car we do have air resistance, so when you do put your hand out, you do feel it. But even with air resistance, it does go forward first before it goes backward if you're traveling forward. All right,